So basically think of the entire field as a big heat exchanger, and we're circulating water through this enormous heat exchanger out here in the field. And that water is being circulated back to the central plant building, and in the summertime we're getting about 58 to 60 degree water that we can use for cooling, and that'll get circulated out to the buildings. It'll pick up that cooling. If it needs to be cooled a little more, the heat pumps actually use Freon to cool it a little bit more if it's needed. That then will be exchanged out at the buildings. It'll pick up the heat from the buildings, carry it right back out to the field, and dissipate that heat into the ground. All right, and then it's returned back again to the geo plant. We've found that with our North Hall installation, we've got a year's worth of history now. We pretty much see a steady 58 degrees coming from the field and about 60 to 61 degrees going back. So about a 3-degree differential. And of course that process is reversed in the winter time. The heat pumps are reversed. We take that 60-degree water, elevate that temperature with the heat pumps so that we can, properly then heat the buildings. Out on South Campus, we had 300 boreholes put in South Campus. Those are all tied into a central distribution box. The wells are in circuits of 25. So inside this underground distribution box, if we ever had any problems out in that well field, if we had a leak, for example, we can isolate those 25 boreholes by going down into that vault and turning the valve off, right? And that keeps the rest of the well field working while we're working on that repair. So that's very good redundancy built into that well field. Right here is our feed from the well field, this pipe here. And if you follow it along, you see it goes right into the machine, right? And then coming back to the well field is this big pipe. So it sends it right back out to the well field. And we got pumps on this end, or the geofield pumps, and that's what's circulating it to the machine, those two right there. And then circulating it back to the well field. So the water comes into the machine, feeds directly into these heater chillers, these multi-stack units. There's 3 modules. Each module has 4 compressors. These work, they're heat pumps, so they're reversible.
So they're heating now, and in the summer they chill?
Well, they can also cool now if it's needed. So these 3 modules can be, one module can be in a heating dominant mode, providing heat to the buildings. This module could be cooling. Okay, so buildings, depending on the occupancy load, right? So for example, in the wellness center, if we have an event in South Gym and we have 200 people in there, the room's going to start heating up, and through valves and through controls, it's going to say, hey, we need to cool down in here. So it'll kick on a module to cool, and valves will open up, and that chilled water will start going into that room to start cooling it down. So it all depends on where your occupancy loads are around campus. So that's the great thing about this type of system, is you have that simultaneous heating and cooling modes that these can perform in. There's always going to be a cooling loop going out and back, and a heating loop going out to the buildings and back. But whether or not the building uses it depends on that building control system and those valves. So if a room needs more cooling, it'll open up a valve. That chilled water will start going through that fan coil unit in that room. And that's what you have, is in each building you have distributed fan coils for the various zones in that building. Currently we have 3 buildings served by this central plant. We have our wellness center, which is 44,000 square feet of building space. It's heating our pool in the wellness center, and it's heating the spa in the wellness center. The science building, which currently is about 23,000 square feet. The total building's 66,000, but it's only partially occupied. And then our theater building, which is 16,000 square feet. So those three buildings account for 40% of our building space. So right now, this central plant is heating and cooling 40% of our building space here. This system was set up to have enough capacity to add some more buildings to it. So we can add McGregor Hall and we can add South Hall to this building load and not have to do anything more down here. We've already piped out to those buildings, so it's just going to be a matter of tying those two buildings in from that pipe system. Both buildings are hydronic systems, so they're liquid boiler chiller systems. So it's basically a plug and play. We disconnect the old chiller, the boilers from that loop, tied into this loop, and they're ready to go. The really cool thing about this whole central plant is we put in a 1 megawatt solar array on South Campus this last fall, and it's been operating since September. That solar array power feeds right into the central plant transformers. So this building uses that power first during the day, of course. And then what power the central plant doesn't use, that power goes on to the rest of campus and gets consumed.